Good morning and welcome to the Driller Newscast 20th episode. In the past 20 weeks, we've had the opportunity to share knowledge on pressing issues that impact the drilling industry, energy, and water. The last 5 months, we've watched more water rights discussions, including the Bureau of Reclamation's ultimatum to the Colorado River Water Compact states. Either they come up with a plan for reduction or the Bureau will do it for them. They have about 40 days left in that ultimatum. We've seen the infrastructure law, PFAS regulation, and net zero legislation all continue to pick up speed. If you've missed out on any of these great discussions in the past 20 episodes, they are available at driller.com, Apple Podcasts, and Spotify. Please like and subscribe. I'm your host, Brock Yorty, and this week for the news, we'll talk electrification and the Utility Thermal Energy Network and Jobs Act that the state of New York enacted, which initiates proceedings to support and regulate thermal energy network deployment. For our featured story, we have an industry godfather of geothermal, Garen Eubank of Eubank Geo. Along with him being a driller, a rig designer, an engineer, he's also been one of the pioneer advocates of the ground source geothermal industry. He's going to drop some great knowledge on us. But before we find out how to save the planet through geothermal, let's talk safety. For this week's safety talk, I want to talk about working alone. And in our industry of family businesses and not a lot of employees and a labor shortage, I know it happens, and it has happened for years. And we talk about cable tooling alone, and we talk about going and setting up a rig or checking a piece of equipment or jumping down in a hole for just a minute. These are things that we cannot do. And I think about the times that I jumped in that F-150 and I went to job sites and I got out with my air compressor and my toolbox and I climbed down in that pit. There were no cell phones, and I got the job done. Or more embarrassing, I climbed out of the hole and knocked on the door and asked to call on the landline to ask dad or grandpa how I did this jet setting. And it's the gift that we're all still here. And there's many that didn't make it. And we can't work that way, especially in confined spaces, at heights, in areas with added risks. What is our lockout tagout policy? But first, let's talk about our work alone policy. How are we checking in? We have journey management. We have abilities now to have software that shows a person moving or not moving. We need to have check-in systems with our cell phones and know where we are and understand that a customer or a representative needs to be there while we're working on this system. Next, what are the risks for the day, from stored energy to weather to wildlife, other activities happening on that job site? I just tagged out this system, and now I'm going to go check. Do I have my arc flash equipment? Do I have the right personal protective equipment? And again, what is the buddy system? And it can't be he didn't come home and now it's 3 hours past dinner, because we live in one of the greatest hospital societies in the world that can, with proper care, almost get anybody back to 100%. And we need to understand these risks. And we need to know that from a confined space standpoint, one or two people may not be enough. What is our rescue plan? What is our out? What are our risks? And now we're working alone and we need to be checking in on one another. Be safe out there. This week in the news, I want to discuss the Utility Thermal Network and Jobs Act, which was signed into a bill on July 5th by Governor Hochul of New York. This bill amends the New York State's public service law to authorize the state's utility to own and operate thermal energy networks, which charge the state's Public Service Commission with initiating and proceeding to support and regulate thermal energy network deployment. As we get to our main story this week, Garen Eubank will talk about electrification and thermal energy networks. However, I thought it'd be great to pull in one of the industry experts, gurus, who can break this down for us a little bit better. Jay Egg. when I need to call in the big guns and the mentors and the gurus of the industry, it's great to be able to, as you research things, realize that you know the guy. And I happen to know Jay Egg of Egg Geo. And we have a couple questions here. If you get a chance and you're at IXPA or any of the major conferences, sit down in a room and listen to this man. And the amount of knowledge that he is giving all of us as an industry and the way we can advocate for geothermal is very important. So, Jay, how are you doing?
I'm doing great, Brock, and I just have to kick that right back at you. If I had your enthusiasm, I would be doing a lot more podcasts, and you are just kicking butt. So thank you for doing this and inviting me on today.
What does electrification mean for drillers in geothermal?
Well, electrification, first of all, it's important to understand that electrification basically is saying all of our buildings are going to use only electricity as a driving energy source for the heating, cooling, and hot water systems. It's basically the same as saying decarbonizing, stopping the burning of fossil fuels on site. So what it means for our buildings is we can only get air conditioning, heating, and hot water one of two other ways. One of the ways is to put in air source heat pumps, which have those condensers on the roof or outside the building, or to put in geothermal heat pumps, which require typically boreholes. 90% of geothermal systems use boreholes on site. So that's what electrification means for drillers. And the reason why we have the two different types of heat pump systems is because one is the less expensive and more temporary way to do it, and the other provides a permanent infrastructure and a permanent installation and does something very important that goes into the electrification explanation. It takes our buildings and keeps them from peaking dramatically like we saw in Texas winter before last, where the grid gets this huge spike of energy consumption because all the heaters come on at once and draw too much energy. And that's why our governments in the United States and throughout the world are so interested in geothermal, because it flattens the spike. Whatever we see in our air conditioning peak demand in the summertime, which our cities can handle now because we're already air conditioning our cities for the most part, will be equivalent to the wintertime peak demand. So in looking at this, the geothermal is really the only solution, because as we were talking about off camera a few minutes ago, we can either spend $1 trillion for a city or a state upgrading the electrical infrastructure to handle what they will need to fully electrify, or we can spend half or less of that and invest in our drillers and our boreholes and our thermal energy networks and give everybody that permanent infrastructure and start piping thermal energy around to our buildings from geothermal loop fields.
That takes me into our next question. On July 5th, Governor Hochul signed a bill for thermal energy networks. What is that?
So that is fascinating. And this has been something I've been preaching. If you were to buy my first McGraw-Hill textbook, you would see in there one of my chapters is about the fact that a newsman, a news program was interviewing me one morning back in about 1990, and he said, Jay, he says, this apartment complex is geothermal. When will everybody have access to this? And I said, Rusty, that was his name. I said, that when it becomes a utility, a thermal energy utility, and everybody just ties into a pipe out in front of their home or business, then it will be available to everyone. So a thermal energy network looks a lot like a water main system through a city, or even you could compare it to a natural gas main. It's a pipeline that runs along to and provides service to every building in a city or a municipality. But this pipeline, instead of moving just fresh water or just natural gas, which is there for creating combustion heat, it provides thermal energy exchange that feeds heat pumps and chillers inside the building.
And so I've seen some of the schematics, and they show using water from subways in
Yes.
different places. You know, we're drillers, and this is a big industry to us, and we like putting in geothermal boreholes. This sounds like something that would take away from that.
And you know what? That's what we've done here is in a very big picture. If I were a driller, I would think exactly what you just said, because it looks like we're taking boreholes off of the on-site, one set of boreholes per building. And indeed we are. Instead of having, it'd be kind of like, imagine this, if you had, think about when everybody first started drilling wells to get water and putting septic tanks in their yard because they have plumbing. Well, eventually we migrated from that and and we started using water mains and water departments and wastewater. And so it took those boreholes or those water wells out of each and every location. So that's what we're doing here. And while we are using existing moving water infrastructure, such as subways that are dewatering, basements that are dewatering, and using that energy, what it really comes down to is our peak load, which is always going to be in the summer, and most people don't realize that, is still going to have to be satisfied. So all that energy needs to be pumped out of these city centers, and it's going to end up going into, just like, imagine any university project you've ever seen, whether it was done by Northwest Geothermal or MEP Associates or whatever company. They would do a college campus. They don't do the boreholes right at each building. Rather, they pick a field, a green field, and they put in thousands of boreholes. That's what's actually going to happen in these cities. So in New York City, where you have every high school has a football field, right? Suddenly those football fields are going to become bore fields. So will the parks. So will any green space where we can actually put in these boreholes. So the number of boreholes that will go in, I don't know whether it will be more or less, but put it this way, it's going to be more than the current number of drillers can even begin to handle over the next 30 years, if not the next 60 years.
Just in the state of New York alone, the idea of doing 2 million residential homes and thinking in a scope of 5 years, I've run the math a couple different ways, but the easiest way to think of it is 365 drill rigs drilling 3 holes a day, 365 days a year for 5 years straight will get us close.
Isn't that astonishing? And even now, I get one of the most difficult questions for me to field has to do with dealing with contractors, geothermal contractors, meaning the heat pump contractors in New York will call me and they'll say, Jay, how can we get more drillers into New York? We're backlogged bad. And so there's no shortage. And this new law, the Thermal Energy Networks and Jobs Act, or now law of 2022, is going to amp that up tremendously. Because for your listeners, what this law requires is that within 90 days of Governor Hochul signing it, every electric utility in New York has to identify 5 thermal energy network projects in their territory and begin to work on the design and implementation of those. And that's just the beginning. It goes very, very deep. And the other thing it does that's really good for our drillers and really good for keeping people with a living wage is it requires prevailing wage for all the work.
And that's phenomenal. It gives us an opportunity to drill more geothermal. It gives us an opportunity to train Gen Z and the
Yeah,
youngest of the millennials into geothermal and water well. This is a adrenaline shot in the arm of the drilling industry.
it is indeed. And just to let you know, no sooner than we got the bill through, even before the governor signed it, not at liberty to say because I don't know what the holdup is, but we're already working with two US senators who are drafting a bill similar for the federal government to make this a law federally and as part of the infrastructure package. So they aren't wasting any time taking this straight up to the top. They love what they see happen in New York, definitely catches traction.
We appreciate New York for paving the way and your hard work. And next, we're going to go on to talk to another industry legend, Garen Eubank, about the drilling industry and Oklahoma and in situ drilling and exploration drilling.
I am one of Garen's biggest fans, and I hope that everybody pays attention to him because there's a man with a treasure trove of knowledge. So enjoy.
Thank you for your time today, Jay.
Thank you.
Welcome to our Driller Newscast, featured industry professional, or what I'd like to say, frontier, pioneer, godfather, amazing industry knowledge broker, and all around great gentleman, Garen Eubanks. How are you doing, Garen?
Well, I'm doing fine, Brock, and thank you for that very kind introduction. You may have stretched it a little bit, but that's okay.
How did drilling get into your blood?
Oh, dear. So, my family started in the water well drilling business in 1934. Okay. And today I have one brother and five nephews that have drilling companies throughout the United States. Well, mainly throughout Oklahoma. So, we've been at it quite a long time. All right. That's how we got in. Uh, Kind of an interesting story. When I was 12 years old, on a Saturday, Big Chief Oil and Gas Drilling Company needed a water well, and everybody was off for the weekend. And I was 12, and I loaded up and went out and drilled my first solo water well. It was like 50 miles away. So that's how I, got started and did my first one. Before that, I was the worm, okay, on the show.
Before 12, you were the worm, and
Yep.
then at 12, you were loading up and going out to drill.
Man, I was a driller. Yeah. I thought I was, but it was successful. We got good water, and the drilling rig had plenty of water to do their job out there. So that worked really good.
That leads right into my next question. Growing up in an oil and gas dominant state, how the heck did geothermal catch your attention?
Uh, in the mid 90s, uh, all my water well drilling rig customers didn't have any business. And I was trying to think, man, I was building drilling rigs, water well drilling rigs, shallow and gas drilling rigs. And so I was trying to figure out how do I get them some work so they can buy my equipment. And so I went over to Stillwater, got certified as an accredited installer, and went through that. And the whole idea was maybe I could get them moved over to drilling ground source heat pump boreholes. We call them boreholes, not wells. And that might help their businesses. Had a number of them actually do that, and some of them done quite well. Okay, I think my brother and his son have got like, I don't know, 12, 14 million feet of ground heat exchanger they put in. Yeah.
So that was the 90s.
Mm-hmm.
I just recently heard you said the first unit you ever installed. What year was that?
Oh, the first unit I did was in '78. Yeah, and so done a little bit here, a little bit there, and they were all residential. And when I went to get certified as an accredited installer, I'm an industrial engineer. Okay, and so I'm sitting there saying, why don't we have a commercial market? And it looks like to me the commercial would be a lot better because you get on a job site, instead of drilling 3 or 4 boreholes, you might drill 400, you know. And so I figured out right away that the local Earth's thermal conductivity. We didn't have any method to measure that. And so I worked with Oklahoma State and I performed the first in situ thermal conductivity test at the end of 1994. All right. So, I was going all in on ground source at that point.
And before that, we didn't have an in situ, an effective way to do in situ testing.
Yeah, we didn't have the thermal response testing that we use today at both IGSPRA, ASHRA, and internationally. So the professional engineers weren't going to design ground source systems because of the liability of the design of the ground heat exchanger. They didn't know how to do that. We didn't have good software either to model, how these ground heat exchangers were going to take the facility's loads, particularly at peak, heating and cooling. And so we went through that. And so I decided, well, the first thing I could set to solve is work on how to figure out what the Earth's thermal properties are. And so we figured out we can measure the deep Earth average temperature. And so that's our far field or our sink source temperature. And then by rejecting heat in a loop, we could measure its response thermally. And from that, come up with the line slope equation to really figure out what the thermal conductivity was. We were still estimating the thermal diffusivity at that time. Here about 4 years ago, Rick Kleminski and I started at what we call the advanced thermal conductivity testing methodology. And it's not advanced on the thermal conductivity. It's advanced in that it directly measures the Earth volumetric heat capacity. And we're finding that these ground heat exchangers are now changing from a sink source for just the facility into a thermal battery or storage for heat. So that's kind of my background.
And you have a patent for that system.
Yeah, for the advanced thermal conductor. The other one, we developed that. Oklahoma State University was trying to get one done. I was doing one at the same time. They were supporting me. It wasn't a competitive deal at all. And we just let that methodology go out to the industry for free. Okay, it was a good thing for the industry. Otherwise, we'd have been hung up with no commercial projects. Okay, so that's a little bit of a story anyway. That's what part of my background.
The first system I encountered actually watching it operate was as they were planning out Ball State geothermal.
Mm-hmm.
And, the drillers at the time that were there, all great guys, many water well drillers, they go, science is not, we like to jump on the platform, make a lot of disruption, make a hole. Hopefully water comes out of it or we put product in it. Could you break down for the drillers the importance of, that test bore before a project even starts?
Sure. First, I'd like to say there's a difference between production drilling and water well drilling. Now, I'm telling you, even to this day, I get a lot of pleasure of getting a water well in and getting that fresh water pumping out, and getting a nice taste of that right, clean water we get from the ground. And so I'm big into protecting the groundwater. I want everybody to understand that. But when we go from drilling water wells, we take our time, we try to minimize the borehole invasion with our fluids and stuff so that we can produce it properly. There's a number of things, and all the drillers there, they know exactly what I'm talking about. But when we get into geothermal drilling or ground source heat pump drilling, it's production drilling. We are continuously adding weight or pull down on that bit to get it to go through that formation as fast as possible, because the driller gets paid when the loop is set and grouted. All right, that's his goal. On a water well, it's when that fresh water comes out, which, like I say, that still gives me a buzz. I like that. All right. So that's basically the difference. But the logistics on managing 7 to 10 or 15 drilling rigs on a site is massive, because you have the drilling, you have the looping, you have the grouting, and a lot of times we use enhanced grouts. The older days, we use sand enhanced grout. Well, the first days we use just normal Montmorillonite clay or bentonite, Western bentonite grout, which is good stuff. Okay. Then we started adding sand to it. From that, we started adding some carbon products to it, which today is mostly what everybody uses. It pumps really well and it weighs less than 11 pounds per gallon. That's good stuff because it doesn't flow out into the porosity and permeability of the formation.
I worked on carbon or graphite grouts in 2008. You know, when I was with Bayreuth, and at the time, finding and sourcing that material was challenging. You know, and it was great to see what other manufacturers were able to do, and you know how the other compositions came together. But that was also, you know, a collaborative feat in trying to figure out how do we, as an industry, evolve that.
Yeah, there's an interesting sideline to that. In I think it was 2011, uh, Oklahoma Gas and Electric, Oklahoma State University, Oak Ridge National Labs, and myself set out to do some research on borehole resistance. The reason borehole resistance is important is if we drill these boreholes and we build a big resistance thermally from the piping to the edge of the borehole with the grout we put in, that's there for the life of the ground heat exchanger. And it reduces its capacity and lowers its efficiency. And so we wanted to figure out what really works. And we had a pretty good deal. To make sure it was done properly, I had the grout, the cement, and the carbon enhancement all packaged together at Packaged Concrete in Chicago and brought down to the locations. Okay. That way I knew exactly what the mixes were. I knew what fluids they were putting in, quantities, and I knew what my output on thermal conductivity for the various mix should have been and was going to be. And we found some interesting stuff on that research. But anyway, we did it, and it's available on the Expo website. A lot of interesting stuff there. One of the most interesting things is on each of those sites, and there were 10 of them, I had elected to run a suite of electronic surveys. Okay. And so we did the short normal, the long normal, the resistivity, the gamma. Then we also did a caliper log and a deviation log. And that really taught us a lot about what was going on down the hole, particularly when we're into production drilling, pulling down on the drill string, putting it in compression. To find out about the deviation, all of us drillers know to get a straight hole is hard to do. Okay. We had a sonic rig there that we had it drill with sonic without any pull down. It drilled pretty fast, by the way. This was a sandstone formation in northern Oklahoma City, and it was 320 foot. Well, our deviation survey showed that the bottom of the borehole was 38 feet to the southwest of where we set up. So those that we were pulling down probably deviated a lot more. And more than that, when we ran those deviation surveys, you could spot right where the key seats were. You could see where the mud rings were. I mean, it was very interesting. And so with that suite, not only could we tell where the borehole went, what the size was, okay, but also how much we invaded the borehole with our drilling fluids. We had some of the drillers there. Our whole deal was let them do what they want, let them size the length they want, and we'll measure it while they go. And we had some that were weighing almost 15 pounds per gallon on the drilling fluids while they were drilling. They were highly invaded. We had a complete swap between the short normal and the long normal. Really evident. So with that, I had documentation of a lot of stuff that we knew from the oil patch. Okay. And Halliburton was one of the other prime investigators on that. IDP is who it was. And so we really had some good help and good people. Dr. Landis pretty well drove that program. If you remember Charlie, okay. Charlie and I had a little deal. He would buy the bills and I would buy the libations. So anyway, we had a great time.
I've worked with Charlie a lot. My roots after my father's drill company was IDP, and as a fluids guy for 5 years in the field, and then another 4.5 years working Latin America, and some other projects for them. And you're absolutely right. And you talk about resistivity. We know how sodium bentonite, along with, native undesirable solids, are building that wall cake. Of course, we've just coated an entire borehole from, zero to bottom, that depending on the type of grout or scouring or what happens, that stuff could be there for the life of the borehole.
Well, it's worse than that because at that differential weight, I've got air on one side or maybe groundwater on one side, I go from 8.34 pounds per gallon to 15, and so I'm going to shove that heavier mass out there, and what it does is it filters out the solids and lets the water go on finally, and so I got this big zone of influence there thermally that I didn't have natively, and so that's important, right? And that's why drilling and good drilling technologies really is important when we're production drilling, because like I say, that borehole resistance is in for the life of that ground heat exchanger. And I didn't want our drillers going out there 10 years later getting sued because their ground heat exchanger wasn't performing properly. Okay. And that was one of the methods I was using to try to attack that a little bit. And IDP has been really good on helping people understand and do that. And so I commend them. Okay.
Yeah, we got some great mud manufacturers out there that have
Yep.
all
Yep.
done their best and have some legends of their own. And that's full circle. So in production drilling, we absolutely want 1,000, 1,200 feet a day.
Yep.
If we're getting hired to be the first rig on site to do those 2 or 3 test holes, how do you think they should approach those?
Well, I'll tell you what we've done here in Oklahoma. Okay. And when we do an in situ thermal test, it's usually on a commercial project, Brock. And so we look at that very first borehole that's going to go out and have that in situ test done. And it may be later used as part of the heat exchanger. And we deem that as exploratory. All right. So that it has a little bit to do with liability about what may happen and all that sort of stuff. From then on, when they come and drill the production, the remaining boreholes, if they stay within that horizon that the test borehole was done, it relieves that obligation and liability to some extent. They're still licensed, they're still responsible, they've got to do the completions properly, but it takes that extra what if. And I'll tell you why that's important. My brother was on a project in, I believe it was in Ohio, and the test was done at 300 feet. The engineer designed it at 375 feet for the next set of all the boreholes. They drilled down there, and in about, just a little bit past 300 feet, they started getting flow back in their pit. Uh-oh. So he stopped. The flow kept coming. Pretty soon it was over the top of the derrick. They had drilled into the top of an unknown gas storage area, and it was a terrible mess. It was on a school project. And so that's why it's really important. And, luckily the guys at the Oklahoma Resources Board understood what I was trying to say. Okay. The difference between exploratory and developmental. And so that was a mistake to drill past that depth on the exploratory borehole. That, a little bit of caution that people can use. Don't go past that.
I don't know a geoscience, geologist, engineer, or hydrogeologist that doesn't look at a driller and go, 5 more feet. I just want to see 5 more feet.
Well, you know what? We're used to turning to the right, damn it. So that's what we do, okay. Yeah, that's okay. 5 more feet, I get more money, and that's what we think. When in fact, stay within those boundaries and horizons that we have on that first test borehole or the exploratory borehole.
Absolutely.
Yeah.
So you've been in this industry a long time, and you've seen the highs and the lows of the geothermal industry. How do we talk to our drillers about that and say, geothermal is here to stay and it's only going to get bigger?
The best way to explain that is along the lines of beneficial electrification that's happening out there. And the only way that they're going to heat and cool all these facilities is with heat pumps. The only way we're going to have efficient heat pumps is to connect them to a water loop. And it could be a ground heat exchanger. It could be an ambient temperature loop. There are a number of ways. But when we do that, we moderate and control the usage and the peaks in a very big way. Where if it's an air source heat pump, even a cold climate heat pump, which a lot of people are doing a lot of salesmen's proffers on how great they are, the issue is with really hot or really cold outside air, they don't work. They lose capacity and they lose efficiency. Where the ground source unit, if we design the ground source heat exchanger properly, we can meet those peaks and extremes very well. The math works. This is not complicated stuff. You can compare Ohm's laws, Fourier's law, and Darcy's laws, and we can see how this works. It's straightforward. So we can design these things really well, as long as we have done a good job on managing the loads in the facility. We've got to know those hourly on commercial jobs. Residentially, we can do the peaks and what we think the run times per month will be and add that up and get there. And then, get a little slop and we'll extend it just a little bit. But that doesn't cost a lot of extra money. When we go commercially, we got to know what we're doing. Okay. So that's kind of a roundabout answer to what you were saying there, Brock.
So the future of drilling geothermal boreholes, if I'm listening right now and I'm thinking about, I got pretty big load on water wells to do right now, but I think I've had success in the past, but I've backed off because of the tax credit. Do you see the future of a company being able to have a second rig that's running geothermal pretty consistently if they invest in the training, the time, and the credibility?
Yeah, the drillers that I'm working with, they're booked up for the year. Okay. And the reason there's a number of them. The first one is beneficial electrification is causing a lot more of these to go in. And the second is we do have the tax credits back. And so with that, along with the utility incentives to manage their demand loads, really help people out. So those can all be applied. So they can either be taken as an extra profit or they can be used to lower the cost. And of course, I want to be used to lower the cost. That doesn't always happen, but that's what we're going. But think about New York. If they wanted to totally go ground source, which they've been proposing, okay, it would take just to get to their first goal, 300 rigs running 24 hours a day to even start to get there. We don't have 300 rigs we can get. Okay. Our industry is great, but I'm not going to get everybody to go out there and do that production drilling. It's hard work. Okay. I'm telling you, you know it. We all know it. All of us drillers know that once you're slapping that pipe around, it'll wear you out at the end of 8 hours. So that's where it goes. The next thing is we have a new thing starting, and it just happened in New York last week. Governor Hochul signed into law the ability for utilities to own ambient temperature loop or thermal districts. That is a monumental change for our industry. Other states will follow suit. Hopefully California does. One of my other companies, we're on the record with the water, the regulatory commission out there to, talk to them about these things and help them make decisions. They have a hard time understanding what this means. All right. They'll end up at the same place, but you'll see that happening pretty well everywhere because the utilities, particularly the natural gas utilities that think they're going to lose sales, they can come in with an ambient temperature loop or community loop, whatever you want to call it, and they'll have a customer that'll last a lot longer than their natural gas system customers. That's kind of important. All right. So it makes sense to them to take and invest their capital into that because they get paid off return on invested capital. So do electric utilities. So if that being said, hey, I think we're going to see some big changes and some big opportunities coming forward for our industry. This is the best I've ever seen it, to be honest with you.
This concludes part 1 with Garen Eubank. Episode 21 of the Driller Newscast will continue our conversation with Garen and the reasons why we should all be in the geothermal industry, along with drilling water wells and other industrial drilling projects. I want to thank Garen and Jay for coming on this week and giving us the full breakdown on why this is an exciting time to be in geothermal and why we all need to be doing our part. Check out thedriller.com. We have all sorts of great content coming out. Come see us at the Jubilee booth at the end of July, beginning of August in Myrtle Beach. Jeremy, Chelsea, and I will be there, and we'd love to hear some drilling stories, good days and bad days. Consider a work alone policy and being safe, knowing the known risks, and how we can all do a better job when we're together on the job and when we have to do that part by ourselves. Be safe, everybody.